Welcome to the discussion around the optimizing networks through network intelligence. This is essentially an attempt to portray how we would whiteboard this to a prospective audience. So let me get straight into it. So I'll start with the first situation, outline the initial participant, and that really, our target audience in the network operator is the network operations team. And if I try and draw them initially, essentially the network operations team are responsible for managing the network capacity in a network operator. Managing the network capacity requires them to plan the build out of new capacity for sales forecasts, also to manage the existing network utilization to make sure it's as efficient as possible with no outages, and thirdly, to, in some cases, support network bids into large enterprise customers. So there's a variety of functions that the network operations team, who report into the network side of the organization and network operator, have to undertake. Let me just go through with you, or take you through a customer example, just to illustrate how this has worked in the past. So essentially, this customer would have a network. Let me portray this network something like so. And in many cases, they have more than one network. So that immediately implies complexity for the network operations teams. The network might have certain capacity already in place. So let's portray the capacity as essentially a box with certain utilization, i.e. how much is used of that capacity, reflected by the shaded in areas. And maybe there's some more capacity out here. So essentially, that's sort of portraying the network, one or more networks. In addition to that, typically network operators will have one or more inventory systems or network inventory systems. In many cases, they have lots and lots of network inventory systems for different purposes, etc. And from that, they're extracting periodically, not frequently necessarily, but periodically, they might take data from these inventory systems that pertains to the network capacity, the configuration of the network, its overall capacity, and the utilization characteristics of that network capacity. In many cases, though, we also see network operations going directly to the network management systems, or to the element management systems, and extracting information directly. So from an inventory perspective, getting the information from inventory gives them a more complete view, potentially, if the inventory is accurate. However, the information gathered isn't always as accurate as it should be. Secondly, if they gather directly from the network, they get accurate information but incomplete information. So essentially, the network operations are sitting in a situation where they're getting a disjoint view of information or capacity utilization information on their network, and they also typically lack or only have rudimentary tools with which they can do the analysis of how to plan and forecast and optimize their existing network capacity usage. So that's sort of laying out the scene for network operations. Okay, so let me take you through the beginning of scene 2 here. Let me take you through some scenarios in which network operations support the various functions that the business is asking them to perform. So the first scenario is I have a sales and marketing group, as everybody has. And the sales and marketing group will issue forecasts, essentially sales forecasts or growth forecasts, into the network operations team. These forecasts can be based on projections going forward, or they can be based on historical growth trends and extrapolated forward. They can be based on one or two quarters or an annual forecast. Typically, the forecasts are becoming much more frequent, so shorter and shorter intervals, much more frequent forecasting. So the forecasts come into the network operations team. The network operations team, with their incomplete and disjoint view of the information in the network, as well as the lack of anything but rudimentary tools with which they can route that forecasted traffic across the existing network. For example, in many cases, these network operations teams, possessing tools such as Excel or Excel-based type of solutions that they've built themselves in-house, they're not able to consolidate the traffic in the network to free up resources to route the new forecasted traffic over. So in essence, what they end up doing, they end up building a just-in-case or a best efforts build plan. So they generate this build plan, let's call it with a B, out to another team within the network operator called network engineering. And network engineering goes down and will build the capacity in the network to support the forecasted traffic. Now, this capacity I'll represent as more boxes, let's say, like this. And maybe there might be some utilization over time of those boxes. Perhaps I need some more capacity in another part of my network out here, for example. Now, what we've seen from our market experience is of the forecasted traffic provided, or the capacity requirements that are forecasted, network operations typically is only able to route that forecasted traffic, about 50% of that forecasted traffic, over the existing network. What that means is they end up issuing the build plan through engineering down to the network for an additional 50% of that capacity. So it's quite an expensive undertaking that they're asking network engineering to do. So essentially what they're doing is they're building the network capacity on a just-in-case basis. So that's kind of our first element. And this represents increased and unnecessary, in many cases, capital expenditures for network operators. And the other thing I would want to mention as well is typically, in fast-growing network operators, their aggregate capacity utilization in their network is roughly 50%, 50-60%. And really, if you can move that capacity utilization to a much higher percentage, then you're much more efficient. Another scenario that we've come across a lot is now related to risk and managing the risk in keeping my network as efficient as possible. So a couple of scenarios I'll mention here. One is the sales and marketing group decide to issue or run some promotions. And these promotions are encouraging customers to sign up for some services that potentially are very high bandwidth consuming services. And this may be somewhat unexpected in network operations or unanticipated or unplanned for by network operations. As a result of these sort of new promotions coming in, this is driving increased network traffic onto the network in this particular case, coming to this point in the network, for example. Again, this is highly illustrative. So what happens here is, because as the traffic comes on, my network utilization keeps creeping up and up and up. Because my network operations teams do not have an accurate and timely and taking frequent updates, essentially from the network or directly or through inventory, their view of the network utilization, the rate of change of network utilization, is rather poor or dated. They don't really have good trend analysis, perhaps, of what is happening in the network utilization. As a result, in many cases, you see situations where the network utilization keeps growing, and then we have essentially an outage because the network gets congested. The result of this outage is that customers start getting dropped calls, or their traffic is not being carried properly, and ultimately they might churn away, and that then impacts you from a dollar perspective. So essentially you have revenue loss through customer churn, customer dissatisfaction, because you haven't managed your network trending, essentially utilization trending, the capacity efficiently. So essentially what you're waiting for here is something to go wrong, and then you're reacting to it. So in essence, from a risk perspective, you're being very reactive in how you manage the network. To give you an example of how this has been handled, or an example from a customer scenario, we have one large mobile customer in India who are growing very rapidly, and they are adding more and more capacity to their network as they grow. However, when we talked to them a little bit about how many outages they encounter on a daily basis, they said to us roughly 22 outages a day. So that gives you an example of the number of the outages that can occur, even though I may have built my network, because it is very unbalanced in how it's being utilized. Now, in a mobile context, perhaps the customer churning here is a prepaid mobile customer may not be as big a deal in terms of revenue loss. If that customer, on the other hand, is a high-end postpaid customer or a corporate customer who may have an SLA with me, having these outages and affecting those customers can be a big impact on my customer loyalty as well as my revenue loss. So this is one big issue. Another point, I think, related to risk that we've seen, if I take these two essentially nodes, or two sites in the same location perhaps, such as two sites in the same city after an M&A activity, many times the network operations have identified an opportunity to consolidate these sites down. However, moving the customer traffic safely from one site to another or one node to another presents a lot of risk to the network operations teams because they don't have the right tools, they can't do it in a risk-free fashion, and as a result, they tend not to undertake these consolidation exercises, or if they do, they have very high risk in execution properly. So the result is they don't do these, and therefore they continue with a bifurcated operation, which is much higher cost. Another example which is becoming more and more important in this particular phase, or this particular situation, is technology migration, where network operators are trying to cap perhaps their existing current generation technologies. They're trying to build out their next generation technologies. Part of that exercise will entail the safe migration of existing customers from the current to the next gen, and then the retirement of the current gen. Again, in many cases, network operations lack the tools and the confidence to be able to enable a migration plan, effectively a risk-free migration plan from one to the other, and therefore they enable the retirement of the current generation technology. So we see lots of operators being forced, because of lack of agility, to continue running the current gen when they really want to get onto next gen. So that gives you an example of several elements of risk: the latency risk, or sorry, the trending risk resulting in outages, being very reactive, as well as the whole risk around migration. Okay. So the final scenario I'll just try and outline in terms of how network operations supports the business. I may have, in many cases, communications bid teams, and I'm going to draw them up here. And these are essentially sales teams in the network operator who, for certain network operators, engage into enterprise customers to sell a large solution into an enterprise customer, such as a multinational bank, for example, or small governments. A whole bunch of services which entail or require build-out of network to support those services. So it could be building out network access into new sites for a multinational, for example, and then a whole plethora of services offered over that network. So typically, the communications bid teams are sending a request into the network operations, asking essentially network operations to quickly turn around a fully costed bid plan with sufficient detail and at a very, very competitive price. Network operations receive these requests because, again, they have incomplete view of the end-to-end network capacity utilization, and because they lack the necessary analytical tools or planning, forecasting, routing tools, etc., they struggle to be able to turn things around. And the result is, the response they give back to the bid teams is one of two. If you want a very quick response, then I'm going to make a sort of a just-in-case build plan to support that customer. And that build plan will be very, very expensive, because essentially I'm going to propose to build a network net new for that customer bid. So it's going to be very, very expensive and take a long time as well. On the other hand, if I'm given lots of time, which is rarely the case, I can come back to you with a very, very slow response, but a little more complete response. That can take person months to get that response back. So the result for the communications bid teams, the results are as follows: that they tend to get very slow responses. When they do get the responses, the detail is insufficient. And then what we've also seen is the cost, the price that is able to be bid in these scenarios is about 20% higher than the price of an optimized bid plan. So it's slow, essentially, and inaccurate. Okay, so that's sort of outlining the mode of operation we see network operations performing in the absence of the Oracle solution. So let me introduce to you now, and I'm probably going to erase pretty much everything. I'm going to introduce the Oracle solution for optimizing networks through network intelligence. Essentially, Oracle is an application called Network Intelligence, which is the main constituent component in this solution. And so what I'll do now, start fresh. So let me redraw the context again. So I have my network operations team. I have down here essentially my one or more networks. Okay, I'm going to put in my capacity. Draw a little smaller this time. capacity comes out in are one or more inventory systems, network inventory systems that are essentially managing or are tracking the capacity utilization in certain parts of the network. I may also have data being extracted from the network still. So let me now try and draw network intelligence, the application. So this is the network intelligence application, which constitutes the principal element of the solution. Within network intelligence, there's a couple of key characteristics. One is it provides a frequent, in many cases on a nightly basis, extraction, transform, and load of information out of inventory or from the network to provide essentially an end-to-end normalized view of the network capacity utilization across the network. So that's the first key element. I now have visibility of my network capacity utilization. The second thing then is essentially a number of analytics modules along with the application. And these analytics modules provide deep functional understanding and algorithms operating on the end-to-end network visibility of capacity to support various functions such as planning and routing, or forecasting, should I say, planning and forecasting, routing of traffic across the network in an optimized fashion, migration, managing outages, a variety of additional capabilities as well here. Another thing that is very, very important in network intelligence is being able to provide fully costed plans, not just a network build plan, but a fully costed network build plan. So we also have integration with ERP, which sits out here. And ERP provides a number of capabilities. One is it provides the costing information for equipment. Secondly, it provides costing information for labor, so I can work out what my full cost will be to deploy a particular piece of equipment, to install it, commission it, etc. It also can, in certain cases, provide information about my lease capacity vendors, how much it will cost for different vendors to lease capacity from certain points, so I can put that into my planning of circuits, etc. So essentially, that is providing the context of the network intelligence solution from Oracle. Okay. So what I'm going to now take you through is those 4 scenarios we went through earlier, and show how network intelligence helps network operations perform their roles much more efficiently and much lower cost. So how it lowers the cost for the network operator, how it lowers the risk in how they undertake their day-to-day manual operations, and finally how it enables them to provide fully costed and optimized build plans for their network. So the first scenario is I have my sales and marketing team. Oops. And again, they're going to issue to network operations their forecasts as they did before. Now, network operations has a much better end-to-end view of the network capacity that's available, as well as the utilization, as well as understanding the trending of that utilization. So is it relatively stagnant? Is it moving very fast? Is it growing or dropping very fast in certain areas? That information is then used by a set of these analytics modules within network operations. These analytics modules are operational in nature. They're very, very familiar or inherently network aware. They understand the different technologies in the network, the different algorithms required, etc. So these are sort of operational network analytics capabilities. So what network operations will do is they will use the plan manager, or forecast manager as it used to be called, the plan manager, to take that network forecast, sales forecast, into the application with the plan manager, be able to work out how they can best redeploy existing network capacity to support that forecasted traffic. And as a result, the application now generates a build plan into network engineering that goes down to the network and builds out the network as we did before. Okay? Now, because we have the intelligence in the the plan manager, we are able to provide a very highly optimized build plan, which builds on a just-in-time basis, not a just-in-case basis. And for example, where previously only 50% of the forecasted capacity, our forecasted growth, was able to be routed across the existing network, with network intelligence, we've seen from real customer experiences, that at roughly 85% of that same forecasted capacity growth was now able to be routed across the existing network, which means I only need to build new capacity for roughly 15% of that forecasted growth. So essentially what this is doing, instead of having my $3 representation, it's now allowing me just to build just what's necessary and do it just in time. So essentially I've moved now from a just-in-case basis in terms of building out my network capacity to just-in-time. And that represents significant capital expenditure deferring as well as reduction from a network operator. This is particularly important when I'm looking to cap existing networks in order to enable me to build new networks. So now we'll talk about how I improve my management of the network and render it more efficiently managed and reduce my costs, which is the key objective here. So in this next scenario, on an ongoing basis, network operations will want to route customer traffic across the network, across the existing capacity that's been put in place in the network. In this particular scenario, there's a few things that network intelligence provides that are of very high value. One is, in the routing manager in network intelligence, it's possible to define routing profiles and policies. What these policies allow you to do as a network operator is to define a consistent manner or mechanism by which you can route customer traffic across your network. Because network intelligence also has costing information, that consistent policy application can result in a least cost, consistent least cost routing approach. It can also bring in certain customer-specific routing policy requirements as well. So that's one thing. As I use the application then to adhere to these policies to route new customer traffic, again, I'm going to develop capacity plans out of the application. And these capacity plans are going to result in network engineering going down to the network and doing a few things. One of the things here is, because I have much better visibility of my network and because I have a very highly intelligent routing capability with the routing manager, the routing manager, I'm able now to make a better analysis and better decision in terms of how I route the traffic across the network. So a couple of examples here. I will analyze my current network utilization, and I'll recognize that I do have an existing path between these 2 points. However, because I have costing information, it might actually be beneficial or lower cost for me to engineer a new connection from this point to this point, rather than tie up ports and links by building dual links all the way around the loop. So essentially I'm enabling, and this is a trivial example, but I'm enabling much more efficient, cost-based routing of customer traffic across the network. The other thing I'm able to do is to identify and allocate utilization of traffic in a more even basis across the network. So I'm keeping things more balanced in terms of utilization in the network. Because I'm more efficient here, the result when I need to lease capacity from other providers I only need to lease $1 worth rather than $3 worth. Essentially, I'm able to provide more and more traffic on net versus off net. So to give you some empirical examples from real customer scenarios, one customer was able to use the network intelligence application to analyze their existing network routing of existing network traffic, and were able to, in the first month, realize savings of about $600,000. So that's a real dollar savings in optimizing their existing network. Another customer looked at how they are using and paying for tail circuits into their customer base from their network, and they were able to realize, again, in a matter of months, savings of about $1.5 million by optimizing the network, building it out more efficiently, closer to their end customer, reducing their need or their dependence on lease capacity to access those same customers. So essentially, these are significant dollar savings that we see here. The other elements here, in terms of optimizing my network, I can identify and release stranded capacity in my network. Typically there's a lot of stranded capacity in networks where you have connections across a lot of elements, but really it's not connecting to any customer or to any service node. So they can be identified, released, and put back into the capacity pool for utilization thereafter. And we also have a very balanced approach in how we address the network. So essentially, all of these elements, making my network more efficient, reducing my dependence on third parties, etc., render my operations to be much more efficient. And that impacts my operational cost of my network on a month-by-month basis. First one is capital expenditure, second one is operational expenditure. So coming back now to the third scenario we went through before, when my sales and marketing, this is the risk scenario essentially, when my sales and marketing start running promotions to drive new customer traffic onto the network this way, because network intelligence is taking frequent extracts, transfers, and loads, essentially, in many cases every night, from the network into the application, or through inventory into the application, it's able to identify, because it has a rate of change analysis every day, it can see exactly how the utilization of the network is growing over time. So if there are potential hotspots of network capacity utilization where it's growing very rapidly and it looks as though it's going to hit a threshold or run out of capacity very quickly, network intelligence is able to identify that. And what network intelligence will do is it will route or balance traffic perhaps across other nodes if that option is available in how it routes that traffic. Or secondly, it can put in place additional capacity to support that network growth or traffic growth. As a result, my customers, as they come online, they don't encounter any congestion, don't encounter any dropped calls, dropped sessions, and that preserves or keeps my customers happy, and it avoids customer churning, which is a key element. In addition, if for some reason a particular node in the network were to not be available through, for instance, an act of God or human error in some cases, if an outage occurs, then there is a special module within Network Intelligence called Outage Manager. And what Outage Manager is able to do is able to analyze the customer traffic flowing across these nodes. It's able to quickly put together, using the routing manager as well, a reroute plan to reroute that customer traffic on a prioritized basis across other nodes in the network to restore that customer traffic as quickly as possible. In many cases, we've seen situations where this rerouting of traffic takes place in minutes, whereas traditional means requires hours to days in some cases. Also, the identification of the critically important customer traffic is difficult to do. So that's a key element that Outage Manager, provided here, allows restoration of customer traffic very, very quickly. The third element I mentioned in this particular situation is, again, if I look at these nodes here, let's assume, for example, they could be two sites in the same physical city. And the network operator has identified the opportunity to consolidate these down to one. This will free up real estate assets potentially, as well as make things operationally simpler. Now, there is a specific module within the network intelligence application called Migration Manager. And what Migration Manager is able to do is it's able to analyze the customer traffic flowing across or through each of these nodes. It's able to, with the routing manager, essentially build a reroute plan, an effective reroute plan or a migration plan, to migrate the traffic from one node to another in a safe and predictable fashion. This then allows the network operator ultimately to consolidate and traffic onto one site and retire and free up the assets of the previous site. In addition, and increasingly important to our customers, is the ability to migrate across technologies. So again, customers on current technologies, let's say ATM frame or legacy, etc., wanting to migrate onto the next generation network that they've built and put in place. Again, network intelligence is also used, and the migration manager in particular can be used to create rerouting plans or migration plans to migrate the customer traffic from one technology to another. And this is a key value proposition essentially for network intelligence. This allows, in essence, this left-hand node to disappear, or the old technology network to be retired, and operational savings to accrue from that as well. So in essence, this whole scenario of risk and risk mitigation, enabling people to do things, or network operations to do things to reduce costs in a lower risk fashion, allows them to go from being reactive in how they handle things to being more predictive, which is extremely important. So the final element is for some network operators that deal with enterprise customers, and again, they're trying to bid big deals into enterprise customers. They require a network build-out component. Again, we have the communications bid teams, which I'm going to put on the left-hand side here, just to keep people on their toes. And what they're doing is they're sending in the bid request into the network operations team. Again, network operations is able to, with the full visibility of the network, capacity utilization, and the routing manager and analytics engines that we have within network intelligence, is able to put together a highly optimized and fully costed network build plan. And is able to do that very, very quickly because of the built-in analytics. And as a result of that, the application creates a build plan, or a bid plan essentially, out of the analytics engine back into the communications bid teams. So from our experience, before having network intelligence, it would take roughly 3 person months to generate a network bid. Now it takes about 3 person days to generate one of these network bids. Secondly, the detail of the network, or the pricing of the network bid is roughly 10 to 15% lower, because I'm able to take costing information. I'm also able to optimize any network bid required by having a better understanding of my existing network capabilities. So I'm only building what's required. And thirdly, the level of detail provided in the comms bid is much, much more detailed. One anecdote I'll give is in Europe we had network intelligence being used by a network provider to bid into a large media company to manage the media company's network. Part of the requirements of the bid were to provide a fully diverse network path. What the network operator did, or our customer did, they used the output of network intelligence to provide the actual network build plan, or the bid plan, if you will, to show the full diversity of the design network to support that media company's network. As a result of that increased detail and the lower cost and the quick turnaround, it enabled our customer to win the business of that media company. So essentially, this network intelligence allows the network operator to move from a slow and inaccurate mode of operation for enterprise customers into a fast and accurate and frankly more detailed approach to how they handle enterprise bids. So in summary then, the solution from Oracle for optimizing networks through network intelligence allows customers to reduce their risk, or lower their risk, let's say, both in the capital expenditure perspective, in terms of deferring and minimizing any capital expense or CapEx, continually driving down OpEx costs on a month-by-month basis through increased efficiencies, to reduce their risk significantly by having more visibility and be able to mitigate any risk, having the information to hand, and finally to provide fast and optimized network bids into enterprise customers. So I thank you for listening to this discussion or talk, and I welcome you to ask Oracle for additional information on this topic. Thank you.